Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about integration by substitution.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, the integral of negative 15x to the fourth power times negative 3x to the fifth power minus 5, and that part to the fifth power dx, and we're given a u value of negative 3x to the fifth minus 1, and we need to evaluate this indefinite integral. Now the first thing here is I'm already given my u value. So I'm going to go find my du value, the derivative there. So my du value, taking the derivative of what's given to me, and 5 comes down and we have negative 15x to the fourth power here, derivative of negative 1, constant, don't really need it, and then dx here. Okay? Pretty simple. And so now I want to see if I can provide a u substitution here. Well, notice here, if I have my u value right here, so if I set u to be that negative 3x to the fifth minus 1, which we already have, and then my du is covered by the dx right here, and then negative 15x to the fourth all line up. Okay? And if you need to see it separately, we can write it like this. We have a negative 3x to the fifth minus 1 to the fifth power times a negative 15x to the fourth dx, and now it's a little easier to see where parts line up. My du is written right here, and my u is right here. So we find the integral. We have the integral now of u to the fifth power times, well, du. And now this integral is a lot easier to solve. So we take the integral here. So what causes a u to the fifth power? Well, we raise that exponent, right, taking the integral here to the sixth power, but we put a 1/6 out front. Then we can't forget our plus c. Now notice this, if we take the derivative, 6 comes down, cancels out with the 1/6, and we're left with u to the fifth power. We're good. It is now at this point, I want to plug back in my u value. So this is equal to my 1/6 times my u value, which was a negative 3x to the fifth power, minus 1, all to the sixth power plus c. And that is it. My final answer here is just a 1/6 times a negative 3x to the fifth power minus 1 to the sixth power plus c. We're given this problem right here. The integral of negative 16x to the third power times negative 4x to the fourth minus 1 to the negative fifth power dx. And we're given a u value of negative 4x to the fourth minus 1. And we have to evaluate this indefinite integral. Now, they gave us this u value, and so we can use that for our u substitution. First thing I want to find is my du value, the derivative here. So the derivative of u, well, power rule comes down, 4 comes down, times 4 is a negative 16x to the third power, and the derivative of negative 1 is 0, it's a constant, right? And then we still have our dx, don't forget that. So now the goal is, can I rewrite this whole thing in terms of a du, or u du? And notice we have actually lined up. Our du lines up to be negative 16x to the third power, and the dx right here. And the the u fits right here inside the parentheses. Okay? If it's easier to see, you can swap this around to be a negative 4x to the fourth minus 1 to the negative fifth power times a negative 16x to the third dx. And now that's seen a little easier. So from there, we can rewrite this to be the integral. This inside is a u, right? Negative 4x to the fourth power minus 1 to the negative fifth power times, well, the negative 16x to the third dx is my du. And that integral looks a lot easier to solve. So from there, let's go find what the integral is. Okay, well, we're taking the integral, so we don't need that integral statement anymore. Okay? And from there, then we want to see, well, where are we coming from, right? What derivative causes really that? And so we actually have u to the negative fourth power going on right there. But to counteract that, we need a negative 1/4 out front. Okay? So we're kind of just adding the exponent there. And then make sure we counteract it in front. And then we have a plus c. Okay? Now from here, let's go simplify this a little bit. So I'm going to rewrite this over here. And I'm going to put my u value in. So it's equal to a negative 1 over the 4 right here. And notice we have a negative fourth power. Okay, so if I put it in the denominator, we have a positive fourth power, and my u value is at negative 4x to the fourth minus 1, and we cannot forget our plus c. And that's actually it. We are all done. So my final answer here is a negative 1 over 4 times the negative 4x to the fourth minus 1 to the fourth power plus c. We're given this problem right here, the integral of negative 8x to the third power over, in parentheses on the bottom, negative 2x to the fourth plus 5 to the fifth power dx. And we're given a u value here of negative 2x to the fourth plus 5, and we have to evaluate this indefinite integral. Now the first thing I notice here is that since they gave us the u value, we need to find our du afterwards. So du, the derivative here, take the derivative, 4 comes down to negative 2, negative 8x to the third power, and then that's really it. The 5 goes away, and we have our dx. Now notice this is actually really nice, that negative 8x to the third dx lines up right here, negative 8x to the third dx, and our u here is at negative 2x to the fourth plus 5. So I actually can rewrite this integral to be as such. Integral now of 1 over u to the fifth power, just du. Notice it again. Dx, or negative 8x to the third dx, is that du right here. And then we have the u down in the denominator. Now, for me, I like to take integrals, not 1 over u to the fifth. I like to rewrite this to be the integral of u to the negative fifth power du. That's my personal preference. With that being said, let's go keep that gravy train going. Okay. And so taking that integral here, I have a negative, well, we have to add, right? Add by 1, negative 5. So we have u to the negative fourth power. To counteract that, we have a negative 1/4 out front and a plus c. So we've taken the integral with u, but we need to plug the u value back in. So with that being said, we have a negative 1 over 4. And instead of the u value to be a negative fourth power, I put it back in the denominator to be a positive fourth power. And our u is at 2x, or negative 2x to the fourth. Got ahead of myself writing a 4 there. Let me erase this here. We have a negative 2x to the fourth plus 5, and then we cannot forget our plus c. And that's actually it. I kind of squished it in here, sorry about that. But our final answer here is a negative 1 over 4 times negative 2x to the fourth plus 5 to the fourth power plus c. We're given this problem right here, the integral of 5x to the fourth power plus 5 to the 2/3 power times a 20x to the third dx. And we're given a u substitution value of 5x to the fourth plus 5. And we have to evaluate this indefinite integral. Now, we already given a u value, so we need to find the du value, the derivative. The derivative here, 4 comes down times 5 is a 20, x to the third power, and then derivative of 5 is nothing, don't really worry about it, and we have our dx right here. And this one actually lines up pretty nicely for us. Notice we have a du value that's right here, 20x to the third dx, and u being that 5x to the fourth plus 5. So it's very easy to convert this in terms of u. So we do that, we have the integral here, and we just have u to the 2/3 power, and then that's du. Direct substitution kind of going on here. And that's a much easier integral to solve. So from there, okay, what we need to do. Now, when we take the integral here, what we want to do is add 1 to the exponent, right? So 2/3 plus 1, or 3/3, is a 5/3. So we have a u to the 5/3 power here, but we need to counteract that by putting a 3/5 out front. And then we have our plus c. Notice when we take the derivative, 5/3 times 3/5 becomes just the 1, subtract the exponent by 1, and we get the 2/3. And now at this point here, it's actually pretty simple. We just plug in u that we have in terms of x right there. So we have 3 over 5 times a u value, which is a 5x to the fourth power plus 5, to the 5/3 power plus c. And that is it. Our final answer here is pretty simple. Once you know how to do it, 3/5 times a 5x to the fourth plus 5 to the 5/3 power plus c. We're given this problem right here, the integral of 5 plus natural log of x to the fifth power all over x dx. And we're given a u value of 5 plus natural log of x. and we have to evaluate this indefinite integral. Since we're given a u value, I want to find my du value, the derivative. So the derivative of 5 plus natural log of x is just a 1 over x, the derivative of natural log of x, 1 over x, dx. Don't have to worry about the 5 there. And so now I want to see how I can plug this into my, well, u-substitution. And hopefully you can see we have a x, or 1 over x going on right here, dx, lines up with the du, and the u is at 5 plus natural log of x. So we substitute that in here, and we just have u to the 5th power over, well, sorry, not over, don't have anything there. Whoops, right? So common mistake, u to the 5th power there, and then that 1 over x dx is just the du. And this actually becomes a much easier problem to solve now. So we take the integral, and let's do it right here, take the integral. Again, another mistake here. I'm taking the integral, I don't need the integral. So we raise the exponent by 1, so we have u to the 6th power, and to counteract that, we have a 1/6 out front, and then we have the plus c. Again, to double check, take the derivative, 6 comes down, times 1/6 is a 1, subtract the exponent by 1, we get the 5th power. We're good. From there, okay, we need to, well, we just substitute u in it. It's pretty simple here. 1/6 comes out front, and u is a 5 plus natural log of x to the 6th power plus c. And that is it. Our final answer is a 1/6 times 5 plus natural log of x to the 6th power plus c. We're given this problem right here. The integral of 4 secant of 4x times tangent of 4x times the secant to the 4th power of 4x dx, and we're given a u value which is equal to the secant of 4x, and we have to evaluate this indefinite integral. Okay, now they tell us the u value right off the bat, which makes it a little easier here. Now I want to find my du, my derivative there. Well, the derivative of secant of 4x is a 4 secant of 4x times the tangent of 4x dx. Okay, so if we're using our rules, secant of 4x has a secant of 4x times tangent of 4x times the derivative inside of which is just the 4. Okay, and then the dx there. So now I want to see if I can rewrite this in terms of u du. And at first it does look pretty complicated, but now that we can see some parts, we found the derivative, it actually lines up pretty easily. Notice we have that 4 secant of 4x tangent of 4x dx is just that du. Right here. Put that together, that's the du right there. Okay? And then our u is just that secant of 4x. So this whole thing actually writes down to be something fairly simple here. The secant of 4x is the u value, so we have u to the 4th power. Okay, and this part here I'll put it as u, but not to the 4th power part. 4th comes out here, and then everything else is just that du. Now, doesn't that look like a much easier integral to solve? From there, let's use our power rule of integration. We add a exponent by 1, so we have u to the 5th power, and then we put a 1/5 out front, and don't forget the plus c. Then from here, we just plug in what our u value is. So we have a 1/5 out here, and u is the secant of 4x, so the secant of that 4x, and they tell us it's to the 5th power, so I can put it like that. So secant to the 5th power of 4x plus c. And that is it. My final answer here is 1/5 secant to the 5th power of 4x plus c. We're given this problem right here, the integral of 36x to the 3rd power times 3x to the 4th plus 3 to the 5th power dx. And our u value is 3x to the 4th plus 3, and we have to evaluate this indefinite integral. Now they gave us a u value, so from there I like to find my du value. So my du here is taking the derivative, 4 times 3 is that 12, x to the 3rd power, and then it's just the dx. Ignore the 3. So from here I want to see if I can make this integral look combine something with my u and du. And I think I almost have it. We have a 12x to the 3rd dx, and we have a 36x to the 3rd dx. So what can we do to really fix this so it lines up perfectly? Well, that 36 right there, if I pull out a 3 from the integral, right? Pull out a 3. I'm left with a 12x to the third power, 3x to the fourth plus 3 to the fifth power dx. And we're allowed to pull out these constants. And so now we can see that this 12x to the third power and dx is just our du right there. Okay? And then 3x to the fourth power plus 3 is that u value. So we can rewrite this integral to be 3 times the integral of a u to the fifth power du. Now this is a much easier problem to solve. And that's the beauty of this u-substitution. So let's go find that integral. 3 stays out front. Our power rule says we take u, we raise it to a plus 1 power, so we have a 6, and multiply it by a 1/6 out front, and plus a c. From there, let's go simplify it again. I'm just kind of going over left to right here. 3 over 6 is a 1/2 u to the sixth power plus c. And now let's go plug in our u value. Let's bring it back in. 1 over 2, our u value, which is at 3x to the fourth power plus 3 to the sixth power plus c. And make sure I got it right. I did. We're good. And so again, our final answer here is a 1/2 3x to the fourth power plus 3 to the sixth power plus, there we go, plus c. And that is the final answer. Don't forget the plus c right there. We're given this problem right here, the integral of x times 4x minus 1 to the fourth power dx. And we're given a u value for our u substitution of 4x minus 1. And we have to evaluate this indefinite integral. The first thing I like to do always is find my du at this point. Du here, derivative of the 4x minus 1, is just a 4 dx. Okay, now we have to do some things to see how we can make this integral in terms of u. Well, I have a dx right there, but I don't have the 4 out front. So what I'm going to do, okay, is I'm going to add a 4 there. All right, but I can't just add a 4, right, directly. So if I want a 4 dx going on right there instead of just a dx to have my du, I have to counteract that with a 1/4 out front. Notice I didn't change anything so far. 4 and 1/4 cancel out to be a 1, and we're good. And my u value is my 4x minus 1. Great, got that in, but I have that pesky x out there, and I need it in terms of u. Well, what if I did this? What if I said we have u equals 4x minus 1, a u minus 1 equals a 4x? Well, that'd be great, right? We can directly substitute that in. So instead of an x, if I just put a 4x here, okay, I know I can substitute that to be a u minus 1. But I can't just create another 4 right there without canceling it out. I put another 1/4 out front. Notice, 1/4 times 4 gives me just a 1, and we're still fine. We still have the same integral. From there, the inside's fine, so we have a 4x minus 1 to the fourth power, and we're multiplying that out, right? And so actually we've set up our integral here to work for our u substitution. So let's go simplify this out here and write it in terms of u. 1/4 times 1/4 is a 1/16 here. And then we have the integral. Instead of 4x, we have a u minus 1 times, well, this is just 4x minus 1 is a u to the fourth power. And then 4 dx is equal to du. And it lines up pretty good. Now, this is a key moment to say your prep work ahead of time makes this problem a lot easier. A lot of students don't like to do that. So do that prep work. It'll save you time in the future. So let's go simplify this before I take my integral. 1/16 here, the integral. Let's go multiply that out. U to the fourth power times u is u to the fifth power. And u to the fourth power times a minus 1 is a minus u to the fourth power du. And this is a much easier integral to take, in my opinion. 1/16 stays out front here, and then we'll be multiplying this whole thing by the integral. So power rule, we have u now raised to the sixth power, and put a 1/6 out front, minus u to the fifth power, and we put a 1/5 out front to cancel it out. And then now you can put a plus c in there right now, and I guess I'll do that, plus c here, and we're multiplying that 1/16 by it. Now, depending on how you want to do it, we'll talk about that in a second. Simplifying this out here, 1/16 times 1/6 is a 1/96 u to the 6th power, minus 1/16 times a 1/5 is a 1/80th, okay? 1/80th. Did I mess up? Oh, there we go, I messed up. Oh, if you caught me, let me know right there. That plus 1, see, I knew my answer was a little off here. A plus 1, that should be, I added a 1 to both sides, plus 1. So if you caught that and you knew it, let me know in the comment section below. Let's go fix that. Plus 1 here, that should be a plus 1 here, and a positive here, and this should be a positive right here. Oof, but I caught it before the end, so we're good. Now we have a positive, 1/16 times 1/5 is a positive 1/80th. Now I'm messing up more. U to the 5th power. And then 1/16 times a constant c is like c over 16, but it's just some constant. So we don't really care with that constant, we just know it's the constant, so plus c right there. Now we can simplify and plug our u's back in, this one right here, and put it back in for u, and we'll be done. 1/96 times the u value, 4x minus 1 to the 6th power, plus 1/80 u value of 4x minus 1 to the 5th power, plus c. And that is, after all that, our final answer. We're given this problem right here, the integral of negative 9x squared times a negative 3x to the 3rd plus 1 to the 3rd power dx, and we have to evaluate this indefinite integral. Now we're doing this by substitution, and my gut tells me that inside this parenthesis is most likely the u value that will be beneficial to us. So I set my u value to be what's on the inside, negative 3x to the 3rd plus 1. And let's go find a du now. Du, derivative here, 3 comes down, negative 3 times 3 is a negative 9x squared, and then derivative constant is just 0, don't worry about it, and we have a dx. Now this is lovely now, right? We have negative 9x squared dx right here, that's our du, and our u values inside the parenthesis. So let's go rewrite this now. The integral here, we have u to the 3rd power, well, du. Again, remember, this is my du right here, and here is my u in the inside. Okay? Now this is a much easier integral to solve. Power rule says we have, well, u, I'll do it right here, u to the 4th power, put a 1/4 out front, and then we have a plus c going on right there. Okay? Now we can plug back in u to be negative 3x to the 3rd plus 1. 1/4 here, negative 3x to the 3rd plus 1 to the 4th power plus c, and in my book, you're done. So the integral here is a 1/4 times a negative 3x to the 3rd plus 1 to the 4th power plus c. We're given this problem right here, the integral of 12x to the 3rd power times 3x to the 4th plus 4 to the 4th power dx, and we have to evaluate this indefinite integral. First thing I want to do is find a u value, and my gut tells me the u value is going to be what's inside the parenthesis, so let's try that. 3x to the 4th here plus 4, if we set that as u, we need to find a du value. So du is equal to, power rule, 4 times 3 is 12, x to the 3rd power, derivative plus 4 is 0, don't worry about it, and we have a dx. And this actually works out into our favor. Notice, we have a 12x to the 3rd dx right here. And we have a u right here, 3x to the 4th plus 4. So these two parts here are my du, and this inside part is my u value. It's pretty easy now to substitute that in. So we have the integral now of u to just the 4th power du. And this integral is much easier to solve. So from there, we use a power rule. We have u to the 5th power raised by 1, counteract that with a 1/5 out front. Then we have the plus c. Don't forget it. At this point, we just have to plug u back in. So we do that. We have 1/5 out front. Our u value is a 3x to the 4th plus 4 to the 5th power, if I can write a 5 here, 5th power plus c. So again, our final answer here is 1/5 times 3x to the 4th plus 4, all to the 5th power, plus c. We're given this problem right here, the integral of negative 12x squared times a negative 4x to the 3rd plus 2 to the negative 3rd power dx, and we have to evaluate this indefinite integral. The first thing I want to do is find a u value for my substitution. And I generally go with whatever's in the parentheses and then see from there. So let's do that. Negative 4x to the third plus 2. Now, we want to find our du value, the derivative. So let's do that. 3 times negative 3 times negative 4 is a negative 12x squared. The squared is for taking the derivative there. Derivative constant, 0. And we have a dx here. And this actually, again, works perfectly. Notice we have a negative 12x squared dx lines right up with our du. And the inside part is just the u. Negative 4x to the third plus 2. So let's go rewrite this in terms of u. The integral here of just, well, u to the negative third power du. Much easier to use now. So let's go apply our power rule. And it's a little tricky when we have a negative exponent. Okay? We have to add the exponent by 1. Okay? Think opposite of derivative. So negative 3 plus 1 is a negative 2. But we want to cancel that out and put a negative 1/2 out front. And then we have our plus c. So at this point, we can just plug our u value back in. So we have a negative 1 over, I'm going to put 2 down here. And I'm going to put whatever that u value is to a positive 2 power in the denominator. Our u is a negative 4x to the third plus 2. Don't forget the plus c. And that's it. My final answer here is a negative 1 over 2 times a negative 4x to the third plus 2 to the second power plus c. We're given this integral right here. The integral of 3x to the fifth power minus 3 to the 3/5 power times a 15x to the fourth power dx. And we have to evaluate this indefinite integral. I first want to find a u value. And generally I pick a u value to try first that's inside the parenthesis. So let's do that. 3x to the fifth minus 3. If I set that to be u, I need to find my du, my derivative here. 5 times 3 is a 15, x to the fourth power, derivative constant, 0, and then dx. And now, does this actually line up with our problem? Can we write this in terms of u? And we can. 15x to the fourth dx directly is my du, and my u fits right in here in the parenthesis. So let's go rewrite this in terms of u. The integral now of u to the 3/5 power du. And again, that's a much easier integral to solve. So let's go use our power rule here. We take u and we'll raise that to, well, we add 1 to the exponent. So 3/5 plus 1, or 5/5, is an 8/5. To counteract that, we multiply it by 5/8 out front, and then we have a plus c. So then from here, we can really just plug in our u value. 5/8 times a u value of 3x to the fifth minus 3 to the 8/5 power, and then we have the plus c. And so our final answer here is done in my book, 5/8 times a 3x to the fifth power minus 3 to the 8/5 power plus c. We're given this problem right here, the integral, in parentheses, negative 2x to the fourth minus 4 to the fourth power times a negative 32x to the third power dx, and we have to evaluate this indefinite integral. Well, I want to set a u value here. I got to find that. And I generally pick something that's within the parenthesis here. So if I have a u value of inside the parenthesis, negative 2x to the fourth minus 4, we need to find the du value. Take the derivative. 4 times a negative 2 is a negative 8x to the third power. Subtract the exponent by 1. Then derivative of negative 4, which is 0. And then we have a dx here. So now I want to rewrite this integral in terms of u. Now, I don't have something looking directly like it. I have a u value in here, negative 2x to the fourth minus 4, lines up great. This second part, negative 32x to the third dx, is very close to this du, negative 8x to the third dx. But how can I make it exactly the same? Well, if I pull out a 4 here, okay, if I pull out a 4 from the 32 outside the integral, I'm left with the integral of negative 2x to the fourth minus 4 to the fourth power times, well, 4 divided by negative 32 is a negative 8. So negative 8 multiplication, x to the third dx. And there it lines up perfectly. This last part here is my du, and my inside part here is my u. So now we can write this in terms of u. So we have 4 times the integral of u to the 4th power du. And again, that's a much easier problem to solve. So let's go take that integral right here. I guess that's an equal sign, excuse me. Shouldn't be a little arrow. It's equal. I'm just moving over horizontally. 4 stays up front, multiplied by power rule of the integral. So we have u to the 5th power, and multiply that by a 1/5 up front, plus c. And that 4 actually gets multiplied to the plus c, but it's just a c. Don't worry about it. From there, keep going. 4, so we have a 4/5 kind of out front here. Right? 4 times 1/5 is a 4/5. And then instead of the u, I'm going to substitute in that negative 2x to the 4th minus 4. So raise up the 5th power, then plus a c. And there we have it. A final answer of 4/5 times the negative 2x to the 4th power minus 4 all to the 5th power plus c. We're given this problem right here, the integral of e to the 4x minus 4 all to the 1/5 power times 8e to the 4x dx. And we have to evaluate this indefinite integral. Now I want to have a u value for my substitution here, and I usually pick something that's inside the parenthesis. So let's go try that out. E to the 4x here minus 4. So let's go find the derivative, du. Well, derivative of e to the u is u prime e to the u. So we have a derivative of 4x is 4 times e to the 4x power, and then derivative of minus a 4, well, is just 0, and then we have dx here. Okay, not too bad. Now, notice here, I want to see if I can make this in terms of u and du. The u is right here inside the parenthesis, and my du is actually very close to what we have. We have e to the 4x here, but I have an 8, and I want a 4. If I pull out a 2 from the 8 and put it on the outside of the integral, which we can because it's a constant, we have then e to the 4x minus 4 here still to 1/5 power times 8 divided by 2 is that 4. E to the 4x dx. And now we easily have our du value right here and our u value. So let's go put that in. We have 2 times the integral of u to the 1/5 power du. Now that's a much easier integral to solve. Keep going across now. 2 stays out front, multiplied. Let's use the power rule for the integral here. Okay, 1/5 plus 1, or plus 5/5 is a 6/5, so we have u to the 6/5 power. Multiply that up front by the flip of that, 5/6. Then we have the plus c going on here. From there, we keep on going. Let's go simplify. 2 and 6 cancel out to be a 3 in the denominator, so we have a 5/3 here. And then instead of a u, we can plug in our u value in. E to the 4x minus 4 here, all to the 6/5 power plus c. And in my book, we are done. And so my final answer here is a 5/3 times e to the 4x minus 4 to the 6/5 power plus c. We're given this problem right here, the integral of x times 4x plus 5 to the 3rd power dx, and we want to find this indefinite integral. Now I want to use my u substitution, and I generally just set my u value to be what's inside the parenthesis and see what happens. So let's do that. 4x plus 5 right there. If that happens, our du is equal to, well, derivative of 4x is just 4, and the rest is 0, so we have 4 dx here. Now this is kind of tricky. We have a u value right there, and we have a dx kind of lined up, but we need a 4 in there. So I'm going to do some cancellation and stuff out here. So we keep the integral here. If I want to have the end part to be a 4 times dx, to cancel that out, I'm going to put a 1/4 out in front. Not too bad. But then I still have that x value here, right? I need to put it in, and that's not accounted for. But watch this. This u equals 4x plus 5. If I subtract a 5 to both sides, I have a u minus 5 equals a 4x. Now, can I create a 4x here? Yeah, right? I can create a 4x. So if I create a 4x, x is already there, I created a 4. I need to cancel out with another 1/4 out front. Then we have a 4x plus 5 to the third power. So notice again here we have all little aspects going on here, right? We're writing x in terms of u. So right here, that 4 dx is my du. This 4x plus 5 turns out to be the u value. And this 4x here is a u minus a 5. So let's go rewrite this in terms of u. 1/4 times 1/4 is a 1/16. Right here, instead of 4x, I have a u minus 5 being multiplied by, well, just u to the third power now, times, this is just a du. Now before we dive in here, let's go simplify this a little bit. It makes it a lot easier, okay? Make sure I have it right, yeah. So we have a 1/16 here, integral, multiply this u to the third out. U times u to the third is u to the fourth, minus 5, well, u to the third du. Now this integral is a lot easier to take, okay? I'll put some equal signs here. So 1/16 stays out front, but let's go take that integral here. Integral of u to the fourth power rule is u to the fifth power times a 1/5 out front, that's a u, minus 5 stays out front, times u goes to the add 1 to the fourth power and put a 1/4 out front. Then, I'm going to put this inside of it technically, but I'll explain why in a second. We have plus c going on here. Okay? So let's go multiply this out now, okay? 1/16 goes across the board here, 1/16 times 1/5, and that's a 1/80. And then instead of a u, I'm going to substitute that in. So u is a 4x plus 5. We raise that to the fifth power, okay? So just multiplying that out. Don't forget to do the second part, minus. So we have 5. And over 1/16 times 1/4 is a 64. And so 5 over 64 is right here. And then instead of a u, we have a 4x again, plus 5, directly in, to the fourth power. And granted, we can multiply this 1/16 times my plus c, but it's just another constant, so we'll just leave it as plus c right there. And that is it. My final answer here, let's double check and got it all right. We're good. My final answer is a 1/80 times 4x plus 5 to the fifth power minus a 5/64, 4x to the 4x plus 5 to the fourth power plus c. We're given this problem right here, the integral of 5x times the square root of 2x plus 3 dx, and we want to evaluate this indefinite integral. Now, we're going to use some u-substitution. I need to find a u value. I generally set my u value to be what's inside of something kind of crazy, in this case the square root. So if I set u to be 2x plus 3, what's my du? Well, derivative of that is, well, just a 2 dx. Okay, so I want to see if I can rewrite this in terms of u and du's. Inside the square root's easy, that's an easy u to find. Now, my dx here, well, I have a 2 dx as du. So if I rewrite this end part here to be, instead of dx, just a 2 dx, oops, 2 dx, not 2 times 2, but 2 times dx, I can do that, but I have to cancel it out outside of the integral, multiply it by a 1/2 right there. Doesn't change the problem at all, okay? Inside the square root, I'm going to rewrite that to be a 2x plus 3, and I'll write to the 1/2 power just so we have a place value, because I can put a u in right there. So far, so good. But I have a 5x, and what can I do with that? Well, that actually comes into my u value. If I rewrite my u value to subtract a 3 to both sides, I have a u minus a 3 equals a 2x right there. So I want to have this actually turn into a 2x. Well, how can I do that? The x is there, okay, I have the x, but I want to write that as a 2x, okay, instead. Well, what I have to do then is, I have to put a 1/2 again out front. So that cancels out there, and I still have the x value come down directly, but the 5 still should be there. But could I just put the 5 out front as well? I could. And so right now we have actually a problem, an integral that's exactly the same. Let's double check that. 5 is still there, 1/2 and a 2 cancels out, so we just have the x. 1/2 and this 2 cancels out, so we're good there, and everything's just the same, right? Square root and 1/2 power is the same. So at this point now, let's do our U substitution. Now, 5 times 1/2 times 1/2 is a 5/4. Let's make it a little easy here. Times the integral. This 2x, right, is that u minus 3. And then this part here is my u, and this is my du. All right, so you can see it. So instead of 2x, I have a u minus a 3 here, multiplied by, well, my u to the 1/2 power, times, well, just du. Now this looks like a much easier integral to solve. So let's go do that over here. Okay, I like to write higher if I can. Let's put some equal signs here. I always forget that. All right, 5/4 stays out front here. Okay, and actually, let's go multiply this integral, these u's out. That's actually easier here. So we have u to the 1/2 times u. All right, we add the exponent by 1, so we have u to the 3/2 here, minus 3u to the 1/2 power, and then du. Just making sure I still did that right. We're good. So now from here, 5/4 stays out front. And let's take the integral of the inside here. Okay, power rule. We raise the exponent by 1. We add 1 to it, so we have a 5/2, right? 3/2 plus 2/2 is a 5/2. Cancel it out, multiply by 2/5 up front. Minus, same thing here, 3 is still there. 1/2 plus 1, or 2/2, is a 3/2. Flip that over, multiply up front, a 2/3. And then we still have now a plus c going on here. Simplify this out where we can. The 3's cancel right here, just so we see that. Let's multiply this out. 5/4 times a 2/5. All right, the 5's cancel, and the 2/4 becomes a 1/2. So we have a 1/2 here, and then we have a u to the 5/2 power minus, oops, not equal to, minus. Same thing, 5/4 times what's left over is a 2, is a 5/2, right? U to the 3/2 power plus, and then c here, again, 5/4 should be multiplied by the c, but it's just another constant going on there, so just a c. Now, the easy part. We just plug in 2x plus 3 in for u. So we have a 1/2 here, our u value, a 2x plus 3 to the 5/2 power, minus 5/2 times a 2x plus 3 again for the u value to the 3/2 power plus c. Let's double check that was correct. I have 1/2, 2x to the 5/2 minus 5/2, 2x plus 3 plus c. Perfect. And so my final answer here, if I can fit it all in, is a 1/2 times 2x plus 3 to the 5/2 power minus 5/2 times 2x plus 3 to the 3/2 power plus c. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.